welcome back and welcome to our second look at patterning. The last video that I showed you, we looked at pattern type number 1. We had a constant gap. This would have been an example of that type of sequence. Today's video is going to focus on pattern type number 2, where we experience a gap that keeps increasing by 2, and we'll see why sometimes we think of this as a square numbers type pattern. And then the last thing we will look at, probably in another video, is pattern type number 3, where the gap is doubling. Now before we get into today's focus, I want to review pattern type number 1. And so I've gone ahead and taken the sequence and put it into our t-table. And you might have noticed fairly quickly that our gap here is 2 every time. And you may recall for pattern type 1, when the gap is constant, n times 2 must be in our expression. And then we want to tweak that, so let's look at the first one. If n is 1, then 1 times 2 is 2. That doesn't quite get us there, but if I add 1, it does. Remember to test on another variable to make sure. So when n is 3, then 3 times 2 is 6, add 1 is 7, bang, we've hit it. So we have our expression, and now let's say we wanted to find the 53rd term. Well, then we would write down the expression for finding the value of any given term. We would substitute in the 53, and we would get this. And so we know that the 53rd term in this sequence will be 107. Well, this brings us to pattern type number 2. And in pattern type number 2, we have a gap that keeps increasing by 2. And I want you to take a look at a special set of numbers with me for a moment to see how they work. And I want you to think back to the idea of square numbers. And with square numbers, what happens is we take the counting numbers and we multiply them by themselves. So the first square number is 1 times 1, which gives us 1. The second square number is 2 times 2, which gives us 4. Then 3 times 3 would be 9. 4 times 4, 16. On we go through the square numbers, each time multiplying a counting number by itself. Now, let's consider the gap as we go through this sequence of numbers that we just generated. You'll see here we added 3, here we added 5, and then 7, and then 9, and then 11. And you can see that each time the amount we go up by is increasing by 2. We started by adding 3, then 5, then 7, then 9, then 11, etc. That's pattern type 2, where the gap is increasing by 2 each time that you add your gap. And it is very much related to this idea of square numbers, and we need to remember that all of the square numbers are generated by taking the counting number times itself. So let's consider a typical sequence of this kind. We could, for instance, begin at 5, and then we would move to 8, and then 13, and then 20, and then 29. So there's our pattern. And let's get it into a t-table so that we can start to look for relationships. So our first one in our sequence is 5, our second 8, our third 13, fourth 20, fifth 29. And let's look at the gaps. Here we have a gap of 3, here a gap of 5, here 7, here 9. So our gap is increasing by 2 each time. This tells us we're in pattern type number 2, gap increasing by 2. And whenever you see this, a gap increasing by 2, this means that n times n is in our expression somewhere. And then we need to tweak it with adding or subtracting to make it exact. So let's test it out. Let's take when n is 2. Then 2 times 2 is 4. Doesn't quite get us to 8, but if I add 4, It does get me to 8. So let's check the next one. Here, n is 3. 3 times 3 gives 9. Add 4 gives 13. Hey, it's looking pretty good. Let's do one more. When n is 5, n times n gives 25. Add 4 more gives 29. So I think we've hit it. This is our expression. Let's imagine that we were asked now to find the 37th term. Well, we begin by writing out our expression, which is n times n plus 4. Some of you might like to use this way of writing it, n squared plus 4, because of course these two mean the same thing. Now, n will have a value of 37 in my 37th term, so I substitute that in. And this is an appropriate time to use a calculator, so when you do that, you get 1,369 plus 4. Add them together, 1,373, and that is the value of our 37th term.